Hello, this is question 8 on your June 2019 paper 2 from AQA, and you have this curve with these equations are cubic. The curve passed through point R to 3. The gradient of the curve at R is 8, and we have to find P and Q. So we have to find two constants, and we have two pieces of information. So if the curve passed point R to 3, that means the point satisfies the equation. So we can substitute the y by 3 and the x by 2, and we have an equation that relates P and Q. So x is 2 times 2 minus 45. So we have 3 is 8 plus 4p plus 2q minus 45. If we reorganize, we have 40 is, I'm going to write it the way around. So 4p plus 2q is 40. That's one equation with P and Q. And now, if we use this information, the gradient of the curve at R is 8, we are going to get another equation. The gradient is given by the derivative. So the first thing we are going to do is to differentiate that function. So the 3 to the front and this 1 degree less, the 2 to the front and x to 1 less, and then plus q and nothing else. And we know the gradient at R, so when x is 2, is 8. So when we substitute x by 2, the gradient at 2, 2p times 2 plus q is going to be 8. The gradient when x is 2. So we have 12 plus 4p plus q is 8. And from here I have another equation which is 4p plus q equals 8 minus 12. And this is my equation number 2. If I solve simultaneous equations, I'm going to find p and q. So we have 4p plus 2q is 40, and 4p plus q is minus 4. I can, for example, subtract. It's up to you how you solve them. Yeah, I'm going to subtract, so I get rid out of the p's, and I have 2q minus q is q, and 40 minus 4, q is 44. That's the first one, and then I can substitute here the q by 44, and I have that 4p plus 44 is equals minus 4, which means that 4p is minus 48, so p is going to be minus 12. Yeah, so these are the values of p and q. For the next part of the question, they say calculate the area enclosed between the normal to the curve at R and the coordinate axis. So we are not very sure, and it really doesn't matter. We could find out, but we don't need to. So we have our curve doing whatever it's doing here. We have the point 2, 3 that is in the first quadrant, so point R, which is 2, 3. And we have the tangent and the normal, which is perpendicular to that tangent. So it's going to be something like this. This is not really very perpendicular, but imagine it is, yeah? So this is perpendicular. And what they are asking us is the area enclosed between the normal to the curve and the coordinate axis. So they are asking us about this area, the area of this triangle. So what we can do is to find the points of intersection between the line, the normal, and the x-axis to find this coordinate, which means this length, and this coordinate, which means this length. For that, I'm going to find the equation of the normal, and I know the point, 1 point, and I know the gradient, because the gradient of the tangent is 8, so the gradient of this tangent is going to be 8, gradient is 8, and the gradient of this one is going to be negative reciprocal, minus 1, 8. So the equation of the line is going to be using y minus y1 is x minus x1, is going to be y minus the y of the point, which is 3, gradient minus 1/8, x minus the x of the point, which is 2. This is the equation of the line, and now I need to find point of intersection with this axis and with this axis. So I'm going to do x equals 0, and I'm going to substitute x by 0 here. So I have y minus 3 is minus 1/8 times by minus 2. So from here, y is 13 quarters. Yeah, 13 quarters. And this is this point here, 13 quarters, which means this length is 13 quarters. And now I'm going to do y equals 0 to find the other one. If we substitute y by 0 here, we have minus 3 is minus 1/8 x minus 2, which means 24 plus 2 is 26. So x is going to be 26. So this point here is 26, which means this length is 26. So I'm just going to find the area of the triangle. The area is going to be 1/2 base, which is 26, times height, which is 13/4. And this is 169 divided by 4. I don't have units or anything, so I just leave it like this. Yeah, and that's all with this question.